Hi everyone, and welcome back to this lecture. So in this lecture, we're going to talk about AI agents and how they can act in the world through the use of tools. And this lecture is sort of the culmination of the lectures before that. We sort of talked about context and LLM and retrieval augmented generation embedding systems. And all these technologies fit together inside agents. And so for a while now, we talked about AI agents and sort of this paradigm of AI agents. And a lot of people have been talking about, okay, are we going to have AI agents? And what happened in the last, I would say, 6 months, or more importantly, in the last couple of 3 and 4 months, is that the model capabilities were good enough so agents work, right? So if there's only one thing I wanted you to take away from this lecture is that now agents work. And this is because as AI agents become more powerful, or LLMs become more powerful, they sort of gain this sort of ability to control these complex systems. And once we have LLMs that can do that, we're sort of off to the races, right? In building these tools. And you can think of an AI agent as a system where the LLM acts as the brain, and then you have other parts that combine to form this AI agent. And there's some capabilities we sort of need in an agent, and one is sort of having human control, that in some way we can sort of influence the system. Hopefully, otherwise it's not so helpful, and I think people talk about ASA talk about this, but we have some human control, we tell it what to do. The AI agent usually also can delegate tasks. For instance, it has sub-agents, which is sort of a copy of itself that it can use to delegate tasks or send it to other tools or workflows. There's some environment where it can sort of learn and know what's going on. And it usually has access to both APIs, data, and code, so it can build things. And there are also some form of autonomy, so it can do things on its own. It's going to check something. You can think about a small script that sort of makes it run itself sometimes, and it runs things. There's also constant memory. We talked about sort of context engineering, and this sort of relates to memory that sort of knows what happened before. But it also sort of responds both to inputs from the user, but it can also respond to other types of inputs to the agent. And I think one good way to think about this is splitting it up into context engineering and tool use. And previously talked about context engineering, which is all about understanding. So if context engineering is knowing what to do and understanding the world, like actions or tools are sort of when we do the actions, right? And you can think about yourself as also being sort of constrained in this way, right? Because you can know everything about the world, right? And maybe you feel like, okay, I know everything about AI agents or something else. But this doesn't mean that you can influence in any way, right? Having knowledge is no influence, right? You also need to do actions. You need to take that knowledge to sort of decide what action to do. So you can think about Loop as knowledge gives you the ability to decide on an action, and then you do an action, and through that action you get more information, and then you might do another action, and this sort of loops goes back and forward. And I think you can think of this both in humans and in AI agents. But if you think about this for a while, you sort of realize that the actions is actually what constrains the ability of the model, right? Because if the model only knows, right, it can only understand, maybe it can tell you something so you also understand, right? But it can't actually do anything, right? So this tool use is actually very important. And understanding that sort of what's happening now is that people are building these AI agents to interact with sort of the web and other tools, right? So we're sort of building this agent layer on top where we have AI agents who act on behalf of us. And so this is very important, and sort of understanding how to build these tools is very important. And basically all agents sort of work in the same way. They have some form of agentic loop. And if we go back to sort of context engineering, you can think about what you are doing when you're interacting with an agent is you're improving its context, right? Let's say you're using Claude Code, which is a tool where it codes for you and you can sort of check what it's doing. What you might notice is that, it's not doing what it's supposed to be doing. And then you can think, okay, it seems that either the agent is confused or you did something so it doesn't know what's going on, but it's a mistake, and you can see that it clearly, like the agent doesn't know this made a mistake. So you also need to improve its context by talking to it, saying like, hey, this is wrong, you need to think about this way, right? And you can think of it that sort of the context is what you provide, right? And this is both for doing an action and sort of improving sort of the context, general understanding of the model. So if you tell it like, okay, I want you to search for information, that's also context, but then it sort of knows to call a tool. And this sort of steering is where we are at right now. And you think of this as sort of, as models improve, you sort of need less steering. You can say, hey, build me a website that shows images of puppies, and it's going to do that, right? And you can think of this, over time, more complex tasks are things where the agent sort of on its own can figure out both what context it needs and what tools to call. And this is sort of autonomy for the model, right? And the longer it can run, basically. And there's several agents in this sort of paradigm, and now I'm talking about sort of agent systems that are sort of quite autonomous, and these work in a similar way. You tell the agent what to do, and it figures out how it does it, right? And Codex is a tool from OpenAI. It's sadly just available on Mac, but if you have a Mac, I would recommend you to try it out. And then you sort of tell the system, okay, I want to code something or build something, and it does it for you. And you sort of inspect the context, see that it's not confused, see that it's doing right, and it can also ask you follow-up questions. But you are sort of not looking at the code at all. You're sort of checking the model's context and making sure that the context of the model is okay. And Claude Code is sort of similar tool to Codex in a way. It runs in your terminal on your computer, and then it's sort of the same way. The Claude Code goes off and codes things for you, and you have to make sure that it does the right thing. And there's some differences in the models, but they sort of work in the same paradigm. And OpenClaw is another tool it's open source, which is nice, where you sort of get your own sort of personal assistant, and it has sort of capabilities. We're talking about sort of Claw as a capability of an agent, where it has sort of a harness or a capability to do different things. So you can hook it up to your email, so you hook it up to your systems for coding or other things, and then it sort of can do this for you. But it sort of work in a similar way, where you tell it what to do, and you can sort of steer it a bit, and it does work for you. And all these agents fundamentally sort of work on the same API. So ChatGPT or an OpenAI has sort of a standard API for how we call agents. And there is a concept of tool use, and this has been around for a couple of years. And it makes it so you can tell your AI, your LLM, that, okay, there are some tools that we can call, right? And basically all these agents work through this. That you tell your LLM, okay, you can call a file operation, we can do some search, we can do some execution, we find tools on the web. And you can think that most sort of tools have some tools that are already available, the sort of default tools that they need, like writing a file, or reading a file, or searching on the internet, or maybe running commands, or sort of writing code, like. And but then this can also be extended, right? And what's interesting about this is that anything can really be a tool, and it's very up to your imagination to think, what tools can I use, right? And so this very simple tool, right? You can make a tool that just prints hello world, right? But you can also make a tool that runs bash, which is sort of the terminal on your computer. And then because the agent, or the sort of LLM system, which we call the agent, knows bash, the programming language, right, for the terminal, it now can run any command on your computer. Because what tools it can use is sort of guided by what it already knows. And you can add context to what it knows, or you can tell it like, hey, use this tool that does this that you already know. And this sort of gives you a lot of capability. And this allows you to combine large language models with the previous iteration of coding, which is sort of standard functions. So you can think about this, that you can use any code to make a tool. So it's really, really up to your imagination. And people have done very cool things about this. As I said before, this is sort of a standard API for tool use. And this is sort of the standard API for using LLMs, that you sort of add this, okay, here are the tools you have available. You can of course do it some other way, but I think this is sort of standard way to do work well. And you think of it as when they train the model, they sort of train them to work with these sort of standard ways. And how we work with AI agents and LLMs is becoming more standard. And that's great because we don't want to spend so much time thinking about how we do stuff. We sort of want to be productive. So this standardization is actually a good thing for this, because then we can sort of build on top of this, because the sort of platform is maturing. And here's an example. Here we can sort of get the weather tool. It sort of fetches the current weather for the user. And it knows that, okay, there's another function elsewhere called get weather. And if the user is asking about the weather, it should get the information it needs from the user and then calls the tool to get the weather information. And this is a tool that I built. And this tool just calls bash. And I think one thing that's surprising maybe to you, and I think I really recommend this, is that you really try building your own agent from scratch. But because it's much easier than you think. You basically take an LLM and you get an API key for that LLM, and then you add some tool use capabilities. And because then you sort of understand that, oh, like all this it's not that complicated, because a lot of the complexity is already solved by the models, right? The models already have this capability, and it's sort of either off. Either the models can do it or they can't. But when the models can do it well, then you sort of get agentic behavior, like sort of agent behavior, for free. And of course, this is sort of simple, but it's very powerful, right? Because now our small agent here can run any command in a terminal, right? There's also some other tools, and I think another way to think about this is like you don't have to build all the tools, right? So this is the standard web search tool in OpenClaw, and it's sort of a Brave Search API, and then you sort of okay, you get some free credits for this, and it sort of works for you because you might not use it so much, and then you can just sort of use this tool. And this is sort of a standard model from a lot of software, that you get a so-called an API key with a key, and you might have to add a credit card, and then they charge you based on how much you use the service. And this is sort of a very nice way to work with software, because you don't want to build anything, like everything. So someone else can build some functionality, and you can use this inside your agent or some other software. And so this, you could sort of hook up if you want to have an agent at web search. You don't have to build it if you don't want it, and then you have sort of web search inside your agent. And this sort of OpenClaw also had a web fetch tool, which sort of uses curl, which is sort of standard way to sort of just search for, get files from the internet, which sort of slightly different. But basically think of it as like that you want to extend it so your agent can do a bunch of things, right? And these are sort of standard, but I think your creativity is sort of the boundary for this. Yeah, and as you talk about this, so the bash tool, of course, the OpenClaw also has a bash tool, right? Or they call it sort of exec tool, which sort of executes command in the terminal. And there's some sort of security about this, because of course it can be dangerous if you allow an agent to do whatever they want on your computer. Other tools, there's a tool for like PDF tools. So you can sort of get the PDF and sort of parse it out, which is sort of nice also to handle all the PDFs. And this is sort of a common pattern that comes up, that behind the scenes, this is also actually using an LLM, right? So Claude Opus and some fallback. So behind the scenes, you're using another model, which is kind of clever. And then so you can use it to parse PDFs. And you think of this sort of that you're having different capabilities, so you sort of glue them together to make something coherent. And I think when you're building software, you don't have to build everything yourself. You can sort of think about, okay, this is the end of what I'm focusing on, and then you can add capability from other places. And the users care about that things work, for the most part. Not like how did you build it? It's not as important as, is it working? Is it doing what you want it to do? Right, and this is sort of my favorite XKCD. It's sort of a webcomic, and it's sort of about this. But first I want to say that sort of why tools are so powerful is for different reasons. One of the main reasons is because using tools, we can allow people to communicate using language, which for us feels very nice, right? And I think sort of the ChatGPT and also the other tools are sort of in a way a revolution for UX, because it's very nice to just tell it what to do and it can figure it out, and sort of offloading a lot of computer sort of energy for you, and you tell it figure it out instead of, and you don't sort of also don't have to make all these UXs. You can just have the chat and it works there. And another sort of very cool thing is sort of the agent can act autonomously and solve problems for you. So this is sort of a capability that's very, very nice. And also the sort of cool thing that you can chain tools together to get more powerful capabilities. But this is sort of an XKCD I really like, and it's about the fact that sort of when we're building software, there might be an illusion that we understand what's going on. And I think it's very important to understand, and I think it's very important to understand software, but I think for most of the time we're sort of fooling ourselves, because software that is complex might be very hard to understand. And you sort of want frameworks, sort of testing and other things to sort of make sure that you know that it works. But keeping track of everything is very hard. And sort of the idea then being that you sort of glue together things that you don't understand, rather than sort of thinking, oh, I should understand every piece. And if you're sort of working in a production context, building things, for the user, what matters is how well the tool works. If you understand the tool, it's actually not important to the user. It's very important for you to move forward and to build stuff, but sort of for the user, the tool needs to work. And if an understanding helps you in that, that's very good. But if it doesn't do that, it doesn't matter. For instance, if you tool call some other API and it does something else, that's fine. Yeah, so here's an example of working with these tools. Behind the scene, you can't really see this, but sort of working with my AI and tell me, okay, give me a link to a website to explain how tool use works for AI agents. And then the agent sort of calls it search tool, and sort of searches online and figures out, okay, how should I search? And it gives me this list of function calling guides from OpenAI, and talk with tool use guide, language and agent tutorial, and OpenClaw tool documentation. Yeah, and it sort of knows it's OpenClaw, which is nice. It knows who it is, right? And this sort of pattern where we don't have to tell it how to solve the problem is very nice. Like, we don't have to tell it like, okay, you have to do this in this way. Or you can just tell it, please solve my problem, and it sort of figures out how to do it. And this is sort of nice, and this sort of goes, because the agent has all the capabilities. Like, for instance, it's sort of the reasoning while the thinking. It's a think before it acts, so like, okay, how should I solve this problem? And then it does it. And it's very, very nice. And this is very, very powerful. There's a lot of things you can do. And I think in general, trying out things with agents is a good way to start. And sort of be bold and try things out, because the agents are probably more capable than you think. Yeah, and so this sort of gives us a sort of new bottleneck, and it's our own creativity, right? So I think right now in history, it's sort of a time where how good your ideas are really matter, because sort of executing them and building it out is quicker now, but you still sort of need to be creative and have good ideas. And for instance, you know everything now to build a really great tool to extend capabilities of an AI agent, right? And this could revolutionize how AI agents work. The question is, what's the tool? Like, what's the added functionality we should build that can improve this? And this is sort of trickier than you think. So I think that's also a way to think about how we sort of navigate this sort of age when we have sort of this AI agent, that thinking clearly is always going to be important. And thinking, okay, how can I think from first principles, think about how do things work, how does software work, what's a good solution? Because the AI agents, they're going to build it for you. But if it's a bad idea, it might not work. So spending that time and thinking like, okay, what's a good idea, right, is very good. At the same time, I think you should do that while sort of trying out this tool and sort of learning by doing. So I think both these are important. Yeah. And so sort of extending tools, we think about tools as the capabilities that are inside sort of default by a model. Skills are extensions of tools, right? So they work the same way, but the skills are things that people can extend. And so this is an example of the find skills library, find skills skill from the skill repository, but there are probably more than 100,000 skills. And I would say that skills you can think about sort of as a new version of packages or libraries for code, where you sort of build this in a way where you build it for the agent first. So you extend the capability of the agent through a skill. And also adding skill capability to an agent is also very easy. There's an example in the agent I built where it has a skills capability. You sort of basically tell it, you have a tool to make skills. So if you need to make a new skill, make a new skill, right? That's it. And this can be sort of crazy to think about, but that's actually how it works. So it's very easy to sort of extend these capabilities. And then you can have skills that are modular, and the agent knows that it has skills and knows a description of the skills. And when it's trying to solve a problem, it looks through its sort of description of the skill. Okay, maybe this skill should be useful, right? So this can take some memory for the agent, or context, but it's very nice to have these skills and thinking about you can make modular skills that you or other agents can use. It's very nice. Right. And we talked a bit about security, and I think this is a way to think about this. First of all, that how capable your agents are is sort of dependent on, for instance, this is for OpenClaw. This is not for OpenClaw, this is sort of for the agent I built, but for OpenClaw, for instance, is based on how much information and ability you give it, right? Let's say you allow your AI agent to write all your emails. Then of course it's going to be more capable if you, instead of you don't allow it to write your emails. The problem might be that it makes mistakes. And people are sort of different on like how much they feel safe about this. But I think in general you sort of have this trade-off of security and sort of capability, right? So you want as much capability in a safe way. And there are sort of good patterns to think about this sort of for doing this. You can sort of offload your OpenClaw to some other device. But fundamentally, this is sort of how it works. If you want an AI agent to impersonate you, that's going to be risky because it might make mistakes, especially if it's autonomous. But it's also capability of the agent, right? But in software security, we also might have the problem that the AI agent might expose sort of hidden or sort of secret information like API keys. And here you can see that I'm asking my agent, can you show me the files in current repo? And then it just uses this bash tool to sort of look at the files. Can you show me the content of the .env file, which is a secret file with API keys? And it says, I can't display the content of the env file because it contains highly sensitive secrets, the API keys, which is true. So that's very nice of it, right? And the way to think about this is like, this is using a newer model, the latest model, right? And if you want a safe agent, I really highly recommend you to have as large model as possible. Because if you have a smaller model that's not as smart, it might be easier to trick it. And this is sort of called a sort of prompt engineering, or sort of just like trying to hack the agent in a way to sort of do something you don't want to. And since these systems are non-deterministic, this can always be a possibility, right? And in general, sort of for working with OpenClaw, if you make an OpenClaw, I would not recommend you to expose it in any way to anyone else, right? Because they can just impersonate you and get your information if that feels sensitive. So in general, you think about sort of an attack vector for an agent, that someone just impersonalizes you and tells like, hey, I'm you, just give me my files. And yeah, the agent might not check that. It's like, okay, that seems fine. So there are some security concerns here. And I think you sort of should move forward. I think OpenClaw actually had a very nice system where you started out and then you sort of, yeah, you go through it and you sort of over time learn how to sort of set it up and it works. Yeah, another sort of key pattern sort of comes with OpenClaw in general, but it's very cool, is sort of the idea of sort of reactivity and sort of autonomy in the agent. And the OpenClaw has something called a heartbeat file, which basically sort of once every 30 minutes, it sort of runs a job and checks, is there anything I need to do? And then you can sort of decide like how autonomous should my agent be? What should it be working on? And I think this is sort of a very cool way to think about it, right? that your agent can sort of check, and then you have a file where you tell it like heartbeat.md, where you said like, okay, here's what you should be working on or what you should check. So for instance, my file, okay, it can check my emails, do some other things. I don't want it to do too much, but in theory, I could tell it like, oh, hey, build a course about information retrieval, and it's sort of going to keep working on that. Personally, I don't think the quality would be good enough. It just does it on its own. But in theory, you can think also going forward that for some things, it is of course possible for it to sort of work on things and sort of research things. So this is definitely something that a lot of people are doing. Right, and of course the agent also has memory, and the memory is sort of, we talked about this before, but sort of the memory is sort of the remembering what happened before. And here's an example of files I have. And in general, sort of it saves memory by day, and it's also like, okay, this is something that was important or something it's all about. And here I think one thing that is important is realizing that forgetting things is also important, right? For instance, here I have some meetings that might not be so important, or some things I sort of worked on that didn't prove out to be so important, and thinking about sort of like clearing that out could also be important. And this both for you and for other people, like you can sort of clutter memory. So keeping what's important, it's also good for agents, right? But basically for OpenClaw, everything is stored. So things aren't lost. You even have the logs for the interaction. So everything is sort of stored. That's very nice. Right? And as we sort of talked about the brain, that LLM is the brain of the agent. And you can think about it even now that sort of the agents are becoming better and better. But overall, this is a part you can also swap out, right? So you can have Claude Opus or the latest ChatGPT version or some other open source model. And we have access to Berget. And this is GLM 4.7 you could use just to try out building agentic workflows through these API keys. There are also other models, but you can sort of try out different models. And going forward, it seems possible that sort of these agentic systems will become more capable for like lower cost and sort of smaller models, right? So that we're going to have agents everywhere, right? And as I said, sort of we have free credits here. If you sign up on Berget.ai, you can sign up with this code hackathon26, and then you will get extra credits, and you can use this when you're building your agents. Yeah, and here's some links for how Claude Code works, and yeah, that's it for this lecture. And I'm going to continue to talk a bit about how the sort of the lab, and this the lab about agents. You will build your own agent system, and I sort of have working code here for Minimal System. And the way I think about this for you is, since we said like, okay, you're allowed to use AI tools and sort of vibe code this or use agentic tools for building this, but I would highly recommend you to try out and build your own system from scratch, right? And you can look at my implementation if you want, but I would see if you can sort of try not do that. I'm also going to show you a link for a sort of a nice tutorial on this, because if you sort of get this, that sort of building this agent isn't that hard, right? The framework for it is sort of simple, and sort of understanding that, I think then you can sort of use this tool, right? Sort of building stuff, but sort of having this sort of fundamental understanding is really helpful, because then you understand why agents are happening, you understand how they work, and why this is sort of a paradigm shift. And a lot of that, I think, would say is because we sort of agreed on a standard format for how this works. And sort of over time, of course, when you train the new models, they sort of already know things about agents, and over time they become powerful because they actually learn from the internet about how agents work. So we're going to have this sort of thing where agents, but I think like when you're building this, you can think about like, okay, what part of this do you think is interesting? Are the sort of information retrieval part things? Do you want to see, okay, could I build my own memory system? How would that work? Do I want to implement information retrieval? Do I want to add some kind of RAG or retrieval system sort of for the memory? Do I want to look at like, okay, what actions would be really cool to add? And for instance, like, and I think this is also thinking about like how we can fit this together, right? Because the thing we talked about earlier in the course sort of fits together here, in that the agent has all the software basically we talked about earlier is sort of living inside the agent, and thinking like, okay, how much can we build it? And sort of if you try it on your own and you sort of build it, so you can build it work like a working version of an agent. I think that's very nice. But then I think you can try it. Okay, I mean, now I'm going to try with Claude Code or some other tool. Like, okay, we can extend this. How can this work? And sort of keep in mind that for you, it's very important to understand what's going on and how this system works, because this is sort of fundamentally having good sort of mental models for the agents is very important, even if you get systems to help you code. Yeah, and sort of once the agent is working, you can experiment with added functionality. And one thing that's very cool and might maybe tricky to add would be sort of the compaction, right? So what happens when you run out of memory? And you can sort of also add skills, right? We talked about this. This is an example inside the repo for that. And you can also add a heartbeat functionality. But I think it's sort of up to you and sort of see that through building this, you sort of understand how agent works really well. And yeah, if you're done, you can also try out installing the OpenClaw. And so the fair warning here is that running AI agents can be expensive. So for instance, for OpenClaw, you sort of need a subscription to something like Claude Code or something like that. There are free ways to do it. I think this free model from Kimi K2.5 you can use, but in general, it's sort of good to think about it. It can be slightly expensive to run this model. So you want to figure out a nice way to do it, so to try it out without becoming too expensive. And this is actually a really nice resource that I will recommend you read. And I think it's very important that you sort of grok or sort of understand how these agents work. And I think that's sort of the key to sort of like, okay, how can I build my own agent? And the answer should be yes, you can build your own, and then you sort of have built it so you know how it works. And yeah, and that's it for now. So good luck with the lab.